Hello everyone, this is DSA Zindabad. Today we are going to solve the 25th question of our actual DSA sheet, and the question is max value of equation. Now let's look at the problem statement. You are given an array points containing the coordinates of points on a 2D plane sorted by the x values where points I equals xi comma yi such that xi is less than xj for all 1 less than equal to I less than j less than equal to points dot length. You are also given an integer k. So what is the goal? You need to return the maximum value of the equation, which is yi plus yj plus absolute difference of xi and xj, where absolute difference of xi and xj is less than equal to k and 1 less than equal to I less than j less than equal to points dot length. It is guaranteed that there exists at least one pair of points that satisfy the constraint, which is absolute difference of xi less than minus xj less than equal to k, right? So now, so what is our main aim? Like from the problem statement, we can understand like our main aim is to maximize. What we need to maximize? We just need to maximize yi plus yj plus absolute difference of xi and xj, right? This is our main aim where absolute difference of xi and xj, this should be less than equal to k. This is the main condition which we need to keep in our mind. And here j is greater than I, right? And one more thing which is there, like all these values are sorted by the x values, right? Sorted by x values, right? Sorted by x values. Like will be given an array which is sorted by x values, right? So now let's look at the example so that you guys have a better understanding of the problem statement. So here we have 1, 3, 2, 0, 5, 10, 6, and minus 10. All the points are represented as xi comma yi, right? In the given array, right? So we just need to maximize this equation, right? By following this condition, right? So now just look at the example, like first 2 points satisfy the condition, right? First 2 points are this point, right? From there, you can directly see like xi minus xj. Over there, we have 2 minus 1, which is equal to 1. And the k over there, we have 1. So this is less than equal to 1. This is the true condition, right? And if we calculate the equation, we get 3 plus 0. Like what we need to do, we just need to calculate the value of this equation, yi plus yj plus absolute difference of xi and xj, right? Which will be equal to 3 plus 0 plus 1 minus 2 equal to 4, right? And when we look at the like third and fourth point also satisfy the condition. These 2 points also satisfy the condition, which will give us a value of 10 plus minus 10 plus 5 minus 6, which will ultimately equal to 1. So out of these two values, we just need to take the maximum value. So the maximum would be 4. We just need to return this as our answer, right? So what is our main goal? We just need to maximize this equation by following these constraints, these two constraints, right? So now let's jump into the approach and try to figure out how we can solve this question. So let's jump into the approach, right? So first of all, let's talk about the brute force approach, right? Brute force approach. So we have this array, right? Let's say this is a which is equal to 1, 3, 2, 0, 5, 10, 6 minus 10, and over there we have k equal to 1, right? In the brute force approach, like what we need to do, we just need to traverse over the entire array. We don't need to think about like how many times we need to traverse over the array, right? Since this is a brute force approach, so we just traverse over the array, right? So by following some condition over there, what are the constraints which we have? First constraint is xi minus xj less than equal to k. So we'll just what we'll do, we'll traverse over this entire array, right? And what we'll do, like we'll have two for loops inside this. Like after like while traversing, we'll just maintain a max say value over there, which will be equal to like initially int min, right? And what we'll do, like we'll just check the condition. If this condition is satisfied, then we'll consider this as our point and we'll try to calculate the result. And at the end of this, we'll directly return the result, right? So by like following two for loops and by checking the condition, we'll get our result. So let me just copy paste the code for you guys. So the code will look something like this. Initially, what will directly have something like kind of answer, which will store the answer into it. So we just need to iterate over the entire points, right? This will be the array, right? We just need to iterate over by using two for loops, and we just need to check this condition. This is the condition, which is like xi minus xj less than equal to b. Ultimately, we can write this thing as something like this: xj minus xi, right? And this should be less than k. Over there, xj represent points j comma 0 and xi represent point I comma 0, right? We just need to check this condition. If this condition hold true, then we just need to update our result, right? So now let's discuss the time and space complexity for the same. Since we are using two for loops, so this will require big of n square time complexity, and the space complexity would be constant because we don't need any extra space for the same, right? So now let's try to optimize this approach, right? So now let's talk about the optimized approach. Optimized approach. So now let's first have a look on the equation which we need to maximize. Like this is our main equation: yi plus yj plus xi minus xj, right? So, and there is this condition also: j is greater than I, right? This means x of j is greater than x of I, right? This is the condition. So now, like, we can write this thing like something like this. Like, if we have something a minus b, then we can write this thing, right? Because over there we have b greater than a. So now, following this condition over there, we just need to update our equation. So yi plus yj plus. So we can write this something like this, which will be equal to minus xi minus xj, because over there, what's the main reason? Xj is greater than xi, right? This is the main reason over there. So now this equation will be something yi plus yj plus xj minus xi. So now, like, just club all the values of j and I together. Like, what do I mean? Like, this I and this I will be clubbed together, and this j will club together, right? So now after this, what will have? Equation something look like this: yi minus xi plus yj plus x of j, right? So this is something like we can now we can clearly see, like, if we know this value, like if we know xi plus xj plus yj, right? After, like, if we are at some point j, if we know both of these values, we just need to maximize this value, right? We just need to maximize this value, I guess. Like, by maximizing this, I guess we are good to go, right? So now it's simple. Like, let's say we are at j, then for, like, what do I mean? Let me just add this thing. Let's say we are at jth position, right? So from 1, 2, 3 till j minus 1, we just need to know the largest value of yi minus xi. From all of these values, we just need to know the largest value of yi minus xj. And also, what we need to do, we need to check also, like, alongside with this, we also need to check if xj minus xi is less than or equal to k. Yes, this is the constraint we need to check, right? So, like, what we can use, like, to find the largest value, like, just think about some sort of like data structure over there. Like, what's the best data structure to use when we think of like just maximum value, right? Just of the maximum value. Something comes up like priority queue. I'll say max priority queue, right? So we'll directly use the concept of priority queue over there to maintain the, like, something like this value, and we just need to do the code, and I guess we are good to go. Yeah. So now let's try to code this thing up so that this thing will be clear to all of you guys. So here we are. Initially, we'll have our priority queue, and our remember guys, our priority queue will contain the pair values And the pair values over there are, first one is this value, which is yi minus xi, and the second, let me just write this thing for you. Like first value is xi minus yi, and second value is just xi, right? Remember, guys, like all the values will be sorted according to this value, which is xi minus yi, right? So now after this, what we need to do, we'll have something answer, which will store like minimum value, right? So now we just need to iterate over the entire array points to size I plus plus. So after this, now what we need to do, if xi, like let me just write this thing, if xi minus xj is greater than k, then like over there we have, if this condition holds true, then we have to remove that thing from the queue, because like as it cannot longer contribute to the answer which is given in the question itself, right? So at this point of time, what we need to do, we'll directly pop this thing out from our priority queue, p dot empty, right? And then points of I0, this is the xi value, right? And when you talk about the j value, this will be from the p dot top in the second. Why over this is second, like uh, over there, right? P dot top dot second, right? This is the xi value over there. Like as you can see, like while maintaining our priority queue, second value is xi, right? So we just need to check if like over there we have j, and over there we have I, like xj minus xi. Xi is p dot top dot second, and xj is points I and 0, right? So now if this is greater than k, then what we need to do, we just need to pop from the priority queue, right? Because this answer will no longer contribute to the question itself, right? So now if the queue is not empty, then the top of the queue is having maximum value of yi minus xi, right? This is quite obvious, right? If queue is not empty, right? Then what we need to do, we just need to update our answer, and now we'll just write the equation points of I0 plus points of I1. Now what will have, p dot top dot first, right? What's the first value over there? This one is the first value, which is xi minus yi, right? So now this will be directly stored into our answer. Now, like we also need to insert yi minus xi into the queue, right? So for inserting this, p dot push. So we'll have points I1 minus points I0, and we also need to insert points I and 0, right? We just need to insert all of these values, right? All of these values. So after inserting this into the, we just need to return our answer. So now let's try to run this code. Over there is a typo over there. Yeah. Yeah, this is, now let's submit this. Yeah, our code is submitted. Now let's discuss the time and place complexity for the same. So here we are. Since we are just iterating over the entire array, this will require big of n cross, like at this point of time, we are inserting all the elements into the priority. So for inserting element into the priority, we require big of log n space. So this will require the outer loop. This will require n, big of n, multiply by, like this will require log n. So ultimately this will be big of n log n, right? So the time complexity would be big of n log n, and the space complexity would be like, at the worst case, we are inserting all the elements into a pyramidic, so it will give a big of n space, right? I hope this approach is clear to all of you guys. Thank you so much for viewing the video till the end. Please like, share, subscribe, and comment if you have any doubt. Thank you so much.